we kind of left off yesterday starting to talk about object-oriented programming, but I want to talk a little bit more about that today. Um, so we can kind of get some fundamentals put into place. Okay, so jumping back into here, you'll remember that yesterday we kind of made a person class, right? So the next thing I want to talk about is kind of how to do inheritance in the Java world, and then we'll lead us into a few other things. What? Oh, yes. I thought I had it already set, but I did not. Okay. So you should be seeing IntelliJ up on my screen now. Okay. So I'm going to create a new class, and let's say, we've got persons. Maybe I'm going to create an employee. Okay.
How do you do that in new class?
So I right-click on the package here, and I said new Java class.
Okay.
So that's how I got there. Okay. So I'm going to stick these kind of side by side. So we've got persons, we've got employees. Well, if I think about, what employee might have, maybe we want to say, well, employees have string name and private, maybe have the a social security number, and maybe they have a salary. Okay, so that's just kind of some starting data, right? To say they've got a name, a social security number, and the salary. Okay. In reality, for employees, we might need to track a little bit more data, but that at least gives us a starting point. Okay. So the next question in there, right? Well, what do I need to add? Well, I need to add kind of all the other stuff we talked about yesterday. Constructors, getters, setters. One thing I want to point out that I didn't point out yesterday, there is some tooling in IntelliJ to automatically generate a lot of those things. If you just declare your variables first, your member variables first, you can have it generate it most of those things. And I think that, I forget where, there it is. So if you right click and go to generate, you'll see something like this pop up. And you see there's a bunch of options. So like generate constructor, getter, setter, equals, hash code, toString. So it actually let you generate a lot of that code fairly quickly. So if I say let's generate a constructor, here what it's doing is it's asking me what member variables do I want that constructor to initialize. So if I just click on one, it'll only give me that one. If I hold shift and click, right, so now I've got them all selected. So if I hit OK, you can see it's already given me a constructor that's implemented with those things. I can't remember if it did. Usually, as it turns out with C#, you usually don't need to generate code because, well, properties just make your life so much easier. So usually the code generation is not required. It's actually a bad sign when you need to generate code for your classes automatically, because that means there's a lot of boilerplate code that just maybe you shouldn't be writing in the first place. And a lot of people have said that about Java. It's pretty verbose to do basic things. Okay.
Now, when we're setting up this new class,
yeah,
I remember something with C#. It was like a generic constructor that didn't have any parameters.
Yes.
Right?
You can.
First up, right?
Yes, if you're going to create a constructor that doesn't take any arguments, I would do that first. Oftentimes, I don't add that constructor. Because the problem is it usually puts the object in a bad state, right? So if we think about that, let's say I want to create a constructor here that doesn't take any arguments, and this is supposed to construct an object. Well, what do I set name to? What do I set name to?
No, you wouldn't have anything, right?
Yeah, I don't have any data, right? That's the problem. The problem with an empty constructor is I don't have any data to work with,
But couldn't
right?
you create a complete employee?
I could,
Die in task one.
but let's say I do it this way, and I say this dot name is null, or this dot ssn. Maybe I just set all of these to null, and double salary. Sorry, this dot salary. Right. So let's say I write it this way. Is this really a good employee object at this point? He's got a null name, null SSN, and a 0 salary? Huh? Basically, I mean, the problem is that if I then take that and then go pass it around my program or toss it into the database, which is usually the thing that happens, you take that object and insert it into the database. Now you just have bad data into the database.
I see it has no value, but I wouldn't expect that you would have line 9, 10, or 11 there. You would just have it, and then you can type whatever you want. It's sort of like a free form, where you may have an employee. It's like we just got the name for now. You don't have to put a salary or SSN, but you can put a name, right? That's why you do the other ones.
The catch is, yes, there's sometimes cases where certain things are optional. There are cases where, you know, maybe the salary is unknown, so you give them an option to not enter a salary, and that might be an acceptable place to then do something like that. The catch is that even in that case, I would argue against it. Because what I've seen, anytime I see a program start to add constructors, as soon as you add the second one, you're going to inevitably, it's not going to be long before you need to add the third, and the fourth, and the fifth. And the problem is that because you're passing these parameters to the constructor in position order, like the order that they're in there matters, it can actually get really confusing very quickly if you have overloads for your constructors. So I would generally avoid having any more than 2 constructors, where one of those is all the fields and the other one is no fields. I would generally avoid having anything more than that, because I usually find that leads to more confusion than it helps. Okay?
When you say no fields, you have to put 9, 10, 11. You can't leave it blank. I remember leaving it blank in C sharp. Maybe it wasn't like that.
Well, you can, as it turns out in this case, because what do right now name, SSN, and salary default
it's null
to?
by default anyway.
Well, they're null and 0 by default. Right. Okay. So that's already happening implicitly if I leave it off. So as it turns out, that does the same thing, right? I'm just was putting it in there to give an example to say, well, oftentimes you want to explicitly set it, but that's what's already happening. Okay, so you might do that, and the most common case where you're going to end up needing to put that default constructor that doesn't take any arguments is when you start passing data around. So, for instance, a number of frameworks for saving things to disk, to files, or sending them over to networks, such as sending them over as JSON objects, do rely on there being a default constructor, because a lot of those use it for serialization purposes. So you may need that, but I usually avoid putting those in there unless I have a need to have them. Okay. Another thing I might think in here, now we kind of talked about optionals. Now we kind of talked about the idea that maybe some of these things are optional. Well, as it is, not to skip too far ahead, but the salary, it's a primitive type, right? Double is a primitive type. Can double be null? No, it can't be, right? Primitive types cannot be null. Reference types can be null, right? So there's no way for me in here to say that the salary isn't set, right? Setting a salary of 0 is still a salary, right? It's still a value. Setting a salary of -1, is still a salary. It's still a value, right? So sometimes I would like to allow nulls, right? And with JavaScript, that was easy because everything can always be null, right? You don't have to do anything for that. In the C# world, there's a very nice structure. You just put a question mark at the end, and now it can be null, okay? That's what you do in C#. You just say this can be null with a question mark. Java being what it is, doesn't have those options. What it does have is this, and this is going to be something you're going to have to pay really close attention to. I'm going to change it to double with an uppercase D. Okay? I'm going to change it to double with an uppercase D. Remember,
now it's a reference type.
It is. Because remember that in Java, our convention is anytime we have a class, we start with an uppercase letter. So double is a class. It's imported automatically because it's in java.lang. Double can be null. What it actually is an object that has a little member variable in there, which actually is type double. Right? It's a little box, what we call a boxed type, around a double. So double with an uppercase D is actually an object, and it is actually a reference type. Now, in most cases, that is automatically converted between the primitive type. Lowercase double and uppercase D double, both of those automatically convert most of the time. So you have to be a little bit careful. Obviously, if that conversion, you'll get a null reference exception if it's actually null. So that's usually what we do if we need it to be null. We use the box type, as we would say. Does that make sense? So to reflect that, I also need to go down here and change this to uppercase double. Right? So now that salary, I could potentially pass in null as that third argument. Does that make sense? That's how you make something optional in Java.
And you have to convert it later, parse it, or
you'll have to convert it back to a double. As it turns out, most of the time, as I was saying, it usually automatically gets converted for you. Okay, which is a blessing and a curse. Because that does make your code usually pretty slick to be able to just have it automatically convert it from uppercase D to lowercase d. But A, there's a performance cost to that, and B, that means you can get null reference exceptions where you didn't expect them to be. Because anytime you're saying taking it to the lowercase version, well, it could have been null, right? So anyway, so we've got a basic employee class, right? So we looked at how to generate the constructor. I'm going to now generate the other parts. So again, I'm going to right click and hit generate. And then you'll see that there are options for getter, setter, or this pair, getter and setter, which is what I'm going to do. And just like the previous ones, I'm going to select everything. So hold shift and select everything. Hit OK. All right, so now we have getters and setters for all three of those fields. So I got get name, set SSN, set SSN, get salary, set salary. All implemented. Cool. So that can save you a lot of coding because really the only thing I have to write, just for simple data classes like this, all I have to write is just put in the fields and I can generate the rest from that. Honestly, what that means to me is we really should have just made those fields public and not worried about this mess of getters and setters. And that's some people have advocated for, but that's kind of where the whole question of should Java have properties comes in. But that's how you can make a simple class. Okay, so we've got an employee, we've got a person, we've got constructors, we've got getters and setters for both of those. Now, more than likely, as I said, my kind of goal here and why I need to create another class is I want to create an inheritance relationship, right? So does anybody remember, how can you explain to me inheritance? What does that mean in English? Let's
say, like, if you're talking about, you have a class of people,
Uh-huh.
and you have a class of, like, employers.
Uh-huh.
That's a bad example, but employees.
So there's a specific word that we use where we usually say is a, right? So this thing is a other thing, right? So if I'm looking at this, is a person an employee? Are all persons employees? No, not true, right? Are all employees persons? Probably, or at least they probably should be, right? I would think that all employees are probably persons. The catch is, okay, the problem is, look at what person defines as what you're storing. Name, age, height, and single. Do I want to store that information for my employees? Probably not, right? So I could create an inheritance relationship with these, and defining inheritance is really not that hard. You go up to the top of the class, and what you write is the word extends, and say the other class. So if I say employee extends person, I'm saying, first of all, that an employee is a person, and that it inherits all the behaviors and data from person, which they're putting up there now. That means employee has all four of those properties, which first of all means it's got two names. It's got a name over here and a name over here, and those are actually two different places in memory. And it also means that it's got age, height, and single status, which it probably didn't need anyway, right? So you'll notice that mostly working. You'll notice there's something in red, right? You see there's something in red. The reason that that's in red is because I haven't told it how to construct the parent object, right? So the parent object only has one constructor, right? And it needs all that data, right? So I haven't told it how to call that constructor. So I could, and here's one of the things that usually gets people caught. Let's say I had a default constructor. This is another reason not to have them. Notice that the error goes away. Okay? You notice that the error goes away. What happened? Well, if I don't specify what constructor to call in the parent class, it will look for a default constructor and use that. So this object's going to say, okay, first of all, it has to go do the base constructor first, because that object has to exist first. So it's going to go up here, run this. Name is going to be set to null, age is going to be set to 0, and height is 0, single is false. All that's going to be set, and it's going to come back here and run that. Okay. So you have to be careful if you have a default constructor, because that warning, those safeguards are now effectively gone.
Is that because there's two names, string name, or
why there's
if you took away the default constructor and you got the name on the person?
No, the name is not relevant for why it was giving an error. So the problem, the reason it's giving an error is because I haven't told it what constructor to call. So back over in this world, what I need to do is I need to call that constructor and give it some data, right? So I do that kind of like you saw yesterday. You can use this to call another version of your own constructor. Super is how you refer to the constructor of the base class or the super class. Okay, so super, I need to pass what? I need to pass a name, age, height, single. So I could potentially say, really what we usually end up doing is we then take all those attributes and we add them as additional attributes over here, additional parameters. So this would now have like 7 parameters over here if I was building this out. But I could also potentially default some of those things. So I might say, well, we have the name already. Let's pass that on. 0, 0, false. Right? What does it say? pass second parameter to a short. Oh, because again, this is a short. So I could do that if I do need, usually I need to call the parent class and tell it how to construct it, right? So that gives it instructions for what constructor to use. So that's what it was complaining about. And typically that should be always something you put in there in your constructor. The first thing you should do is say, call the parent constructor, do this. One might ask, over on this side, I haven't done that, right? Over on the person, I haven't called the parent constructor. Why is that? Why is it okay that I haven't called the parent constructor?
What's the parent constructor of a person? Object class, right?
Right. So notice here in person, I haven't said person extends something, right? If you don't specify that a class extends something, it's assumed that it extends object. So you can imagine that it says person extends object. That's actually implicitly implied, okay? Which means that there is a parent class, right? There actually is a parent class. And that parent class does have a constructor that does have to be invoked. How did I get rid of the error a minute ago? I put in a default constructor, right? Well, object has a default constructor because you don't need data to construct the base object. So effectively, it's saying super already. It's already calling the parent constructor.
So you could type extends object on line 5.
Yeah, you could, and it would be perfectly happy. It would do the same thing that it's doing right now.
On the left side, why do you need names? It's redundant, right? That would need to be taken out. Line 13 on the left side. Or line 4, I guess.
Yeah.
You wouldn't need that, right?
Well, so here's the catch. This is I'm going to change some things because this is not the way I want to set things up. Because again, I don't really these two classes don't really have a descendant relationship because the data doesn't match up, right? If I'm creating a inheritance relationship, I'm saying that this thing now needs to inherit all the behavior and data, but that doesn't make sense. With inheritance, you can't remove data. The only thing you can do is add data, right? And the problem is I need to remove age, height, single status, right, from the employee object. So what that means is that the inheritance relationship here doesn't actually hold up as we've written these classes. Is everybody with me with there? So I could work forward with this design. The problem is I need to change my design, right? And we're going to do that here in a minute. What was the thing I wanted to do before I changed that? Remember there was something, but I don't remember what. Okay, I'm going to just go change it. So here's the oh, now I remember what it is. So when you're thinking about inheritance is used for two things. It's used for two things. It's used to reduce your code duplication, right? So for instance, it allows me to only write setters and getters for name once for these shared fields. So it allows me to reduce how much code I write and reduce duplicate code specifically. The other thing it enables is what we call polymorphism, okay? And that's where you can treat one object as something else, right? As a more generic class. So for instance, if employees are persons, then we can treat employees as persons. Any function that knows how to work with persons now also implicitly knows how to work with employees. Does that make sense? So it exists for those two purposes: reducing code duplication and for implementing polymorphism. As it turns out, it's not a good trick for both, either of those two things. Just a hint. It's not really a good tool for either of those two things. But let's fix this. So let's say this is not actually a person. That doesn't really make sense. So, and the problem is that I put too much in the person that doesn't really apply to all of the subclasses of person. Does that make sense? Person should be more specialized, right? So what I'm going to do is I'm going to rename the person class to something else, right? So what could we rename person to? What might be a better name for this class as is? So we've got employees and we got
Maybe just
customers, something like that, right? So if we say we've got a system, yeah, we're usually going to have employees and customers, and they're not going to have the same data, right? It's very unlikely that your employees and your customers will have the same data. So let's rename this class. So I'm going to right-click on the person class over here. Everybody see my cursor? So I'm going to right-click on person. I'm going to say refactor, and I'm going to rename this. So rename here. I'm going to rename it to customer.
Well, why would you have an employee be inherit from customer?
Exactly, because employees are not customers, which is what my whole problem was, right? Because I was trying, that was what I was trying to do, is I define this class person, but it's not really a person, right? So what I need to then reintroduce is the person class, which has the stuff that's shared between them. Does that make sense? So the problem is I'm trying to do this with two classes when I actually need three, right? So let's introduce a third one. So I'm going to say right click here, new Java class. I'm going to add a person. Okay, so now this class can actually be the proper base class, right? So I can look at my two classes that I have. I can look at my customer, I can look at my employee. Is there any stuff that's shared between them? Or should be shared between them?
Name.
Name. Okay. So they both really have a name. Okay, so let's make that in the base class. Let's put that in the base class. Is there anything else that they might need to share? Well, specifically, if I want to put this into the database, remember everything I put in the database typically needs to have an ID, or specifically a primary key, right? So let's add a primary key, some sort of ID to this. So private int ID, that's reasonable to assume that both customers and employees are going to need to have an ID, right? Now, is there anything else that they share?
Male, female. That's not so important to put that in.
That's usually not something you want to track on your employees. Just saying. They might both have an age. Again, even if they have that data, you don't necessarily want to track that data. So once you're starting with looking at employee data, right, your rules are different, right? Your rules are different. So if you are mixing ethnic stuff, whether it be age or gender, marital status, height, those are things you're going to get in trouble with. You're putting those in you're tracking that from your employees. Just saying. Especially if you're tracking in the same database as everything else.
I would think in person you'd want something beyond just, well, I guess that's good enough. I really don't need anything else.
That's really all I need. Because the rest of the stuff is like, you own that data, that's specific to your specific implementation. Okay, those are the only two things they're going to share.
I was thinking maybe there's something else too, because someone could have the same name. The ID would distinguish between the two, but there wouldn't be much else.
So I'm going to say generate, and we'll generate a constructor. So we can generate a constructor there. Okay, and I can generate some getters and setters. And maybe I generate the equals method as well while I'm here. Equals and hash code. We're going to accept next, and we're going to say ID and name are the two things we're going by. Okay. So now we have a nice base class, our starting point for persons, right? Because this actually represents persons, right? I might want to implement the toString method while I'm there as well, so that we can have that for debugging. So I might say in here, let's create a method. So person has an ID and a name. So kind of slap that together, %d, comma, %s. Any questions on that person class? Does that basically make sense as far as what we're doing there? So that's our base class, right? We're going to use that as our base class for both the employee and the customer, right? Okay, so let's start with employee. Okay, so we're going to go in here now, come back here. We're going to say it extends person, which now is going to be fine because person actually makes sense. Okay. Now, if I think about my class here, okay, cool. If I think about my class here now, should I have a name in this class? I already have one in person, right? So I don't want to make copies. And one of the things that you'll see here, which is kind of a gotcha as well, notice it's not complaining that there's two names, right? Notice it's not complaining that there's a name here and a name in person. It's just perfectly happy to accept that, right? Perfectly happy to accept that. So one of the things I typically find that I want to do, the problem with marking it private is that only that class knows about that field, right? So this employee class has no idea that there's another name field. They can't access it. So there can be two things with the same name. So one of the things that I usually find better to do is go back to this class and type in protected. Yeah, there. So I'm going to mark both the ID and the name protected. Okay, that does the main thing that does. It means that all the subclasses can access it. The other thing it does is because they can now access it, they also can't use the same name. So in here, I believe it should be giving me an error. I think it's getting caught on this, which I need to fix. But it should be in a moment giving me an error, the fact that, hey, you also have name here. So if I want to call the super constructor, right, remember, what does the super constructor need to take? It needs to take an ID and a name, right? So I need to provide it an ID and a name. But where do I get the ID? Where do I get the ID? Somebody. Corey. Corey, where can I get the ID? Well, I need an ID, right, to construct a person. Right? So the constructor for person needs an ID and a name, right? But when I go in here, I have a name, but I don't have an ID. How do I solve that? Well, the person hasn't been constructed yet. I'm constructing the person. I can't ask for the person's ID until I've constructed it. Somebody else. What can I do? What can I do here? Would it be okay if I just passed in 0? Is that a valid solution? The error goes away. Huh? Right. Every time I create an employee, they get ID 0. That's not a good solution, right? So what I need to do is I need to add an additional argument here, which is the ID. Does that follow? So oftentimes you may need to, as you're kind of reworking things, you may need to add additional bits to your constructors as you realize, hey, I forgot some data. Because employee should probably had ID to start with, but he didn't.
So when you construct an employee, it'll automatically...
Well, whoever calls this constructor has to provide one. Whoever calls the constructor, it's their job to figure out what to set the ID to. Okay.
Which would fill in for person as well.
Yep. So that goes down to person. And so the thing that we would have liked to see still, and I'm not seeing, is that it gives me some sort of indication that name occurs twice, but it still hasn't done that. I swear I've done that with Java and it's escaped it. But the thing I want to do is get, the point is, what I'm trying to get to is I want to get rid of the name that I have in the subclass, because otherwise I would have 2 names. Cool?
You would need to get rid of...
I would have 2 places in memory.
Wouldn't line, can't see the line number there. This name?
Yes. Yeah, so that would go away. I wouldn't have these. Right? So I need to kind of trim the class down a little bit to just the stuff that's there anymore.
And the order for the public employee ID surname, there's that line that.
Mm-hmm.
But as the order, you should put it up front, but it really doesn't matter. It doesn't have to come first.
What doesn't have to come first?
Well, it's like, for example, you got string and salary.
The fields?
SSN and salary.
Yeah.
You can put that first.
Yeah, all of this can be in any order. You can put your constructor anywhere you want. You can put your methods anywhere you want. You can put your fields anywhere you want. But I would ask, always put your fields at the top. Because you can see how much of the class they drive.
Right.
And if I were to, for instance, and I've seen actual developers do this. We've got one field up here. I'm going to go mix another field down here, and probably they added it in. Like, oh, they said, hey, I need a salary, so they added it down here. Please don't do that. Please don't do that. Because now I look up at the top, and I think that's all the fields it has. But there's another field that's declared all the way down here. So technically you can declare them anywhere you want, but in terms of readability, it's a big deal that they should be at the top.
And so if there's another class underneath employee, then you would, that list of, I don't know, what would be underneath employee, maybe
You're
like
thinking
supervisor.
down here?
Maybe like supervisor, something like that. That list of things, ID, name, SSN,
Right.
salary, it just keep growing, right?
Right, yeah. So if I created a supervisor, which is a subclass of employee, yeah, then it would take all this stuff and add its own. Right? So like maybe I put in there like, what department are you supervising? Things like that.
Yeah, so it can get quite big.
Yeah, it can get quite big.
Do you have to include everything in there? Like maybe one for the supervisor, if you're the CEO
In the
of
constructor?
company, most employees will have it, but
If it stops making sense, then maybe your class hierarchies is wrong, right? So if you get to a point where you say the CEO shouldn't have all this data, well then maybe CEO isn't a supervisor, right?
employees sort of.
Maybe. Maybe,
Yeah, okay.
maybe the CEO is a person. Maybe they don't even behave like an employee. That depends, right? So sometimes, sometimes those may fit in there. Sometimes they may be a completely another class in and of themselves. So similarly, we want to go to customer, and you'll notice it didn't change any of the comments. So, boo, 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 boo. So this is going to be, remember, keyword extends. That's the word you want to remember, extends. In C#, you just put a colon there, so it was colon in the name of the class. But in Java, it's the word extends. So we're going to say extends person. Remember, we needed to remove the field name. I am going to mark all of these protected because I do find that usually that future-proofs me better to mark my fields protected instead of private, just for reference. So we're going to say that, and then we have the same kind of issue. This is trying to call the parent constructor. What does it say? It says there's no constructor that takes no arguments. So I've got two options here. I have the option I can go add another constructor in person that takes nothing, or I can just fix this line here to pass the data. Always do the latter. Because the error it tells you is like, well, you need to add, if you read the error, you think, well, I need to add another constructor. That's the problem. Well, no, the problem is you need to pass the data. So int ID, and so we're going to pass those things down. So ID name. And same way with here, because the ID exists in the subclass, in the parent class now, we don't need to define these methods here. Now, other things I might want to do, let's say I have my equals method here. My equals method is kind of wrong now because notice that it's not comparing the ID, right? So I need to actually update that as well as the hash method to add the ID here as well as add the ID in here. So we would say this dot ID equals other dot ID. Okay. Where are you looking at? I can do these in any order I want. Really. The thing that you've got basically two options. You've got one option is to do them in the order from top to bottom, the same order that they basically exist in the class, which you can think of, this is a subclass of person, so you've got age, height, and single, but all of the things in the superclass come first. Does that make sense? So really, this is kind of the order that they exist in. Your other option to do is, and this is a little bit better in terms of performance because doing what we call a deep comparison is a little bit more expensive. Comparing to strings is more costly than comparing primitive types. So we usually do the reference types at the end. So that's your options. You either do them in the order that they're declared, or you do them with the reference types at the end.
If you redid that equals using the built-in features and IntelliJ, would it do that? What you added in on line 39?
Yeah.
Return this ID.
If I were to regenerate it, basically regenerated that. Well, I think, actually, I'm not sure if it would generate it the same way, actually. It would probably call the parent class. It would probably call the superclass, which I might as well do that here. Let's see what happens. So if I call if I generate this again, it probably will be a little bit different. So generate equals and hash code. Hit next. Yep. Age, height, and single. And yes. As as expected. So what it changed it to is it calls this, you see super dot equals. It calls the parent class's implementation.
Wow.
So if the parent class says they're not equal, then it goes ahead and it says we're done, right? So if it already compared the ID and the name and said that those are wrong, in reality, it actually generated the wrong code because that's the right code. Sort of. I think the first check probably is worth keeping, but this second check is actually no longer needed because it already exists in the parent class. Right? This line here, if I were to look in the parent's implementation, that's already exactly here. So technically, I don't actually need to keep this line. So that's what it does. So you say use the parent's version. So it's also doing the similar thing with the hash, uses the super's version of hash, and then add your fields.
What you deleted, that would break it, or is this not necessary?
This won't break it because it already exists in the parent class.
Okay.
So this second check is not necessary. It's actually just double work because it has to now do it twice. Now, why does it say there are problems here? Two related problems. Oh, probably because I haven't gone and fixed my main class, which is now all sorts of broken. So if we come back here, we want to construct a customer. Well, there I just need to give it an ID. Maybe I'll just say give it ID 5. Point is, I need to come up with a number somehow to construct it.
Or just randomly generated, right?
Well, usually what happens is either the object already exists and you're pulling it from, say, the database, and so you just take the ID from the database. Usually, if we're constructing a new object and then putting it into the database, we usually just start with like ID 0 and let the database figure out what the actual ID is. So oftentimes we use 0 as kind of the flag to say that it doesn't have an ID, and that also works on the premise that usually your IDs in MySQL and most flavors of SQL generally start at 1, not 0. So 0 is not a valid ID. Does that make sense? So I could put a number here. Usually I'll end up constructing that with ID 0. Okay. So that's kind of, so we've created two classes that are a subclass of that person, right? So you started to see some of that superclass base class behavior, which is kind of important. Okay. So remember, what were the two things that I said that this inheritance is good for? What does it give us? It gives us two things. What were those two things that I said? Huh? You're close. What did I say? You're close. I used some different words.
Not just big structure your code, you got a hierarchy.
I got some hierarchy. Reduces repetition. Usually we call that code duplication, right? Where you've got the same code in two different places. So it reduces code duplication because all of the functionality that I've written into person, right? Whether it be the fields, the data, the ID of the name, and all this other stuff, this is already pre-built, right? So I don't have to reinvent it for all the different kinds of persons, right? So it helps with code duplication. What was the other thing that I said? What is the other thing that this gives us? The other thing that gives us is what? It's one of the major parts of object-oriented programming. Modularity. You get modularity just by creating classes. Yep.
Polymorphism.
Polymorphism, right? What is polymorphism?
Where you can use one object as another.
Okay. So if I go back to main, for instance, so I've got my first person, right? And so I can look at it there. And this is, let's say I construct a new customer. So here I'm going to call this, change that name. So we're going to construct a new customer, give it some data, but I'm going to save it to a variable of type person, right? So you see on the right, I've got customer. On the left, I've got person. So it's getting automatically casted from a customer to a person, right?
And it's never the other way around. You wouldn't put customer,
Right.
customer person,
So
new person.
if I say, let's try it. So customer P is equal to new person, right? So what data do I need for that? Well, maybe I need, let's say ID, let me say ID1, and I'll make this ID2. So ID1 here, and I'm just going to call this, person. Okay. Yeah, I can't do that because remember, what's the relationship with inheritance? I'm saying that a employee or a customer, I'm saying a customer is a person, but the behavior doesn't follow the other way around. So for instance, you know, I've created this person. Does this person have a height? Do they have an age? So they aren't customers. I don't have all the data there. You know, the relationship is one way. So I can't treat my persons as customers, right? So remember I talked about there's this difference between downcasting and upcasting. So if we're talking about the hierarchy, we've got a person up at the top is the base class, and down there we have employee and we have customers, right? So I can safely upcast. That's fine because all customers are employees, but I can't safely downcast. Downcasting is not safe, but upcasting is.
Never do it.
So upcasting happens automatically. You don't have to tell the compiler to do anything specially. You just do it. I just say, I want to treat this customer as an employee by saving it in appropriate variable. But if I want to do it the other way, I have to say, yes, I know this is dangerous. I'm going to do a downcast, right? So that's where I could say, well, in here, let's downcast it. Let's say this thing is actually a customer. That's what I'm doing right here. I'm saying ignore all the safety warnings, just treat it as a customer because I know better.
Okay.
Am I wrong? I'm still wrong, right? This doesn't make it right. And if I try to run the program, rather than it telling me at the compile time, it'll tell me at runtime. Person class cannot be cast to customer because it's still not true, right? So I can make the error go away, but I didn't solve the problem. Does that make sense?
Yeah, so if we're doing this, it's always going to be the highest level, even if there's two levels down, like there's a subcategory underneath customer, you would still do person P equals new.
Yeah, you could still do that. I mean, it's still valid for me to say customer is customer, right? You can always have the same type on both sides. That's acceptable.
Yeah, sure, but I'm just saying, like, if we're dealing with these inheritances, just use the highest level.
No, most of the times you use the same class that you declared at. Usually on the left and the right, you're going to have the same class.
You are going to upcast it, just use the highest level.
No, I wouldn't even make that rule of thumb. I wouldn't make that rule of thumb.
Why even bother upcasting?
So the reason that I would upcast is because, and I'll do this in a minute, I want to put these into an array of people, right? So that's the reason that I'm going to do an upcast, is because I want to, what I'm trying to get to is an array or even a list of people, right? That's my goal. And that's where I want to be able to treat them similarly. Okay, so if I have that, so I have this, so that's what I'm trying to say. So you can force it to do a downcast like this. You can say, go ahead and treat it as that, but that doesn't mean, right, that it will be converted to a customer. Does that make sense? This casting doesn't change what it actually is. It just changes how you treat it, right? But the problem is you can't do that if it's not actually already that. So downcasting is typically not a conversion. Does that make sense? That only works for primitives types that you can do that as a conversion. Doesn't work with reference types. Now, where I could have done that, where that would have been acceptable, let's say I go in here and I have this customer, right? Let me put that in a person variable here so that stops screaming at me. If I wanted to say customer is this valid? Because this guy is a customer, even though the variable I'm putting him in is a person, right? He actually is a customer. Does that make sense? When I said new customer. So that's a case where I can downcast. Here I can downcast safely because it actually is the thing.
How is it downcasting at the same level?
Well, what type is customer? What type is that variable? It's person, right? So right now I have a customer stored as a person. I can safely downcast that to get back to the customer. Does that follow? So basically the downcasting you only do if you for some reason have an insight to know that it actually is something else already.
With this situation that we're doing here, there's not a lot of value with just initiating a person equals new person. It's just an idea and a name. That's not very useful.
In this case, it's not useful because I'm creating a customer, saving a person, and then putting it back in the customer. That isn't valuable here, but in larger code, you'll see this happen.
Yeah.
So what I'm trying to get you is just some insight to what you're eventually going to see. Does that make sense?
It's situational. You just kind of know.
Right. Okay. So we've got those. So I've created a person object. I've created a customer. Let's also create an employee. So person employee is equal to new employee. Somebody give me a name for this employee.
Sam.
Sam. Okay. So this is Sam. And what is Sam's salary?
100,000.
100,000. Okay. Okay. Actually, I need to put it in the social security number. So let's make that 1, 2, 3. Okay. And that needs to be a double. So there I need to specify that it's a double.
Is that a Be a big D, wouldn't it?
Could be either. It's actually the same thing. Whether you say lowercase or uppercase, it's the same thing. Remember lowercase L and uppercase L, same thing.
No,
Same
but our it was a double with a capital D, wasn't it?
It is. Remember I said how things get automatically casted? This is a primitive type double, lowercase double. It's automatically casting it to an object. And we call that boxing. If you automatically gets converted to the object, it's boxing. If you're automatically pulling it out of that box, well, it's unboxing.
How do you know it worked? Just because there's no error?
Yeah, basically. So we've got three objects here, right? And remember, hey, one of the pieces of functionality that we declared that all of those have, they have a name, right? So I can go in here and I can say, let's do p.getName, and let's go p.getName, customer.getName, employee getName. Right? So I can call getName on all three of those things because remember they're all base class of person, right? So person, customer, employee. Okay. Now in reality, this is kind of weird, right? This is kind of weird that I can just construct a person, right? Because at this point, is that really useful to have a person with just an ID of the name? Probably not. In most applications, that's not helpful, right? So I probably want to prevent them from creating actual person objects, right? Anybody remember what I can do to prevent that? It's actually the same thing as C#.
What's the question again?
So I want to prevent them from creating persons. They can construct customers and employees, but no persons. Remember what keyword I need to put in? What keyword do I use for that?
Are you talking about like private, public, protected, package, all that?
No.
Restricted.
So there's a keyword that says you can't construct an instance of this thing. You're a little muttering, but I'm hearing the answers.
Static.
Static. Well, what does static say? Static says it belongs to the class, and it says that you can use it. You use that field and that method exists outside of the class. Not exactly the same thing. So what I want to do, I can go to person class, and I'm going to put in here the word abstract. Do you remember abstract? Abstract says I can't construct an instance of this. Okay. So now that my person is abstract, I can't just have people floating around here. They have to be one of the subclasses, right? So that means if I go back to main, this is going to say, oh, you can't do that. Cannot do that because person is an abstract. You can't instantiate those. Does that make sense? That's an important thing to remember with your base classes. Usually your base class will be abstract. Usually. Not necessarily true. If I just had what we started initially, persons and employees, well then probably neither of those two classes would be abstract. But usually what you have is some sort of shared class that can't actually be constructed. Usually that's the way we architect things. Okay. So that's good. So what I was trying to get to, remember, is I want to put this stuff into an array, because that's kind of the whole point of having polymorphism. And that's where that, having the inheritance, right?
Where did you put the word abstract?
In the person. So I put public abstract class. Public abstract class. So what I'm going to do in here, let's say we want an array of let's say we want an array of people. So I'm going to comment out all of that code here. So people array. Why is that red?
We don't have a class of people.
We don't have a class of people, we have a class of person. So you got to remember that typically your class is going to be the singular form of it, right? So your class represents a single thing versus your variable, right? I'm going to call it people because it's an array. It's multiple things. So I'm going to say new people, new person array. And so let's say we have three persons. Okay. So now I can start filling that array with people. So I can put in here my customer. Comment a little bit. So I can put in my customer. Let's put in my second person, people 1, and that's a new employee, right? And give me another person. Should the third person be a person? Should be a customer, or should it be an employee? Be a customer. Okay, I hear customer. Name? Somebody give me a name. Huh? Mo. Okay. We have Mo. And he has an age. Mo, what's your age? I don't think I can hear you. I saw Mo's things light up, but I don't actually hear him. So if he said anything, I didn't hear it. All right, so give me an age. 20. Okay. 20, height. 19. 4'3". Okay.
Yeah, 4.3 centimeters.
All right, and what's the last one? Okay. All right, so we've got that. So we've got an array of people, right? Yes.
Your customer on the first customer
What happened? Oh, he's missing a name. Okay, so we'll do that. Okay. So what I can now do, right now that's an array, I can, treat it like all of them they're a thing, right? And this is where the polymorphism is really strong, is because now this array, right, I can all treat it as people, right? So let's say I want to loop through that. I'll just use a enhance for, so person, P, and we're going to iterate through the people. Okay, so for each person, let's go do something. Well, probably easiest thing to do is to just print their name. So for each person, let's go print their name. System.out.println, p.name, get name. Okay, cool. All right, so that's a start. Now, what if I want to go through here and what if I want to maybe print out some other things? Like, what if I want to print out their age? Right? I could names just fine because all of the people have a name, but not all the people have an age, right? So I've got a problem. Everybody see that? Because, well, what kind of people have ages? The customers, okay? So I could work around this and say, let's cast it to a customer. And now, the way I do parentheses here is kind of important because you notice I just put customer there in front of it and it didn't fix it. The problem is that's casting the final result to a customer. It's casting the age to a customer, not what we want. So what I want to do is cast P, so I have to add another set of parentheses to clarify that I'm casting the person to a customer. Now, why doesn't it like that? Oh, because we never implemented that method. That's why. So, public short get age and return this age. Okay, so now it's happy. So if I cast it down to, I say, okay, these are customers. Watch what happens. So the first one, it's okay, because the first one actually is a customer, right? I can get Paul and I can get his age, and that works. But then I go to Sam. Sam, I can get his name, but when I try to cast him to customer, it fails.
You'd have to use an if.
I need some sort of if, right? So I want to only do that if there actually are customers. And this is, as I said previously, you only do that when you know, right? You only do that when you know that they're actually the thing. So the way that you check that something is particularly that class is you use the operator instance of. Instance of is your operator in the world of Java. So I'm going to say P instance of customer. So if it's a customer, then I can print out their age. And otherwise, no. Okay, cool. What if I want to do something for the employee? Well, same thing. So I say if P is an employee, then I can say, well, let's cast him to an employee and then get the salary. Does that make sense? So that's how you can deal with it. And so we effectively have some sort of polymorphism behavior. But sometimes we need to step out of that a little bit. You know, polymorphism's good up to a point because I can either get name, it's good. Sometimes I need to call some of those methods in the subclass, which means I need to know, is it a customer or is it an employee? So that's how you kind of break into it. You check instance of, and then you downcast it. So that's where, again, upcasting is always safe. Downcasting, you just have to check first, right? Okay? Questions so far? So we talked about classes, we talked about inheritance. We went a little bit, you see some polymorphism. So we've looked at, encapsulation. That's where we've got our private or protected fields. and then we've given those getters and setters to access her. So that's kind of how we're implementing that encapsulation. We're hiding those fields that state behind the class, their implementation details. We've seen inheritance, polymorphism. I think those are the three. I feel like there's a fourth one, but I can't remember. So the next thing to do, and we kind of mentioned interfaces yesterday, right? So an interface is kind of like an abstract class, right? Kind of like an abstract class. The catch is an abstract class is just the only rule about abstract class is it's a class that you can't construct, right? It can also have, if you remember, it can also have abstract methods in there as well, which is basically the same syntax as C#. When I'm building an interface, what I'm really saying is that here's some functionality that any class or many classes could potentially implement. Because one of the rules in both C# and Java is that you only can ever have one base class. Okay, I can't say that this employee is both a person and a string. It's one or the other, right? I can't make it a subclass of more than one. Cool? But you can make it implement as many interfaces as you want. There's no limit to how many interfaces you can implement. Obviously, there's a limit because you don't want your code to be, your file to be ginormous. And it really doesn't need to implement every interface that exists. Okay, so let's say we want to make an interface here. So we've got persons, we've got employees, we've got customers. What might be something that might be shared additionally between customers and employees? What might be some shared functionality? What can they maybe both do?
They can both buy stuff.
They can both buy stuff. Okay, so they can both purchase things. So maybe we'll make a new interface. So up here, I think it's actually hidden under Java class, but I'm actually going to tell it I'm going to construct an interface. You can see that with the I. So I'm going to construct an interface, create an interface, and we'll maybe call this purchaser. All right, so anything that implements that interface is able to buy things. Does that make sense? Another way you could go is say, well, we'll make them accounts. So anything that's an account can log in. All right? So in the purchaser method, maybe I'm going to say we need to declare a method. So I might say that this purchaser can buy things. So buy, and maybe I would want to buy a product, but I don't have products here, so I'm just going to use object rather than create a product class, because we don't really need it.
What is that on that line? Void. Not returning anything?
Yep, so this method doesn't return anything. Notice I've left off the access modifier. Do you see that?
Doesn't return an interface?
No.
Public interface purchases.
Yeah, so everything inside of that interface is what you have to implement to be one of those things, right? So I have to be able to buy to be a purchaser. Does that make sense? So this in here is a method. Just like you would declare methods in classes, this is a method.
The void is a method, or the public interface purchaser.
Buy is the method.
What is it?
Buy is the method. This is the method name. That's the return type. I'm saying that this method returns nothing.
Why are there no curly braces?
Because remember, just like abstract methods you don't implement. The interface methods you don't implement. You're going to say the actual class will take care of that. All you declare is the signature for it. It's worth noting if I try to put public here,
It's public by default.
it is public by default, and sometimes it'll yell at you and say you don't need to mark public and you shouldn't.
Yeah, you wouldn't use that if it wasn't public, right? I mean,
So,
it would be there and unusable.
yeah. Well, it's because it's an interface. If you're building an interface, you're saying this is external functionality. So inherently in that, it needs to be public. Because otherwise, what's the point of having an interface if you can't use it, right? So inherently, the public is implied. So unlike classes where you need to include the access modifier all the time, you don't need to include the access modifier in interface. Cool. So here I'm declaring that in order to be a purchaser, you need to implement the method buy. And the other method I might want to do, if I want to be able to buy things, I might need to know how much money you have to buy that. So maybe I might have something in here as well to say get balance. Right?
You got spelling there.
I do. Right, so I can find out how much money you have in your account, and I can purchase things. Good enough? Probably would need more in there, like know where to ship it and things like that, but it's a start, right? So let's say I've got that. I want to now use that interface. So the first thing I need to do is I need to have some classes actually implement that interface, right? So I could go all the way up to the top and I could say persons, well, they implement purchaser. The catch then, if I say person implements purchaser, then every person has to be able to purchase. But that's not necessarily true, right? It may be that the CEO, for instance, the CEO is probably never going to purchase something. He owns the company. Plenty of other people, maybe you have your delivery people that are bringing in, driving the trucks and delivering goods to your vendors. Your vendors are probably not going to purchase anything, so they don't need to be purchasers. So I'm only going to apply purchaser to the ones that are actually going to buy something. Does that make sense? So of those two, let's say that the customer implements purchaser. So you can see the keyword extends is for your base class, implements is for the interfaces. Do you see that? So two different keywords.
So an interface is kind of like a flag for a certain capability.
Yes, effectively, right? So there's a lot of interfaces in the system, things like comparable. Comparable says that it can be compared with something else. Serializable says that it can be saved to disk. There's some way to serialize it. There's forgetting what the other ones are. But there's a few of those that kind of, it's basically defining, here's the functionality that you have to provide to be that thing. But for all intents and purposes, now I can treat, if I implement this, I can treat all customers as purchasers. So I can have an array of purchasers, or I can have customers, I can store them in a purchaser variable, I can pass them around to functions, but I can treat them as purchaser objects. Okay.
So implements, that's the word we use for interface.
Yep. So you say implements this interface, and you'll notice on the class, on the interface, I don't say public class purchaser, I'm saying public interface purchaser.
Right.
That keyword is what defines it as being an interface.
Implements only used with interfaces.
Right. Yeah. So in here you'll see that it's red because I haven't actually implemented. I declared that I will, but I haven't actually done it. So I'm going to go up here and I'm going to say implement methods. This pops up. I'm going to say yes. All right. And then I need some way to implement these things. Right. So what should I do with get balance? I could say, well, you always have X amount of money, right? And that would be one way to do it. in reality, to have that balance, I probably need to add another field, right? I probably would need to back that by some sort of field. Does that make sense? And then I would need to say, so this would really probably say return balance, but for the moment, I'm just going to say return 10,000 because I want to move on to the next thing. And then we're going to say maybe in here, well, this would be where you would say, you know, balance maybe minus equals the product dot price, right? Remove that from your balance. Does that make sense? So whatever you define in that interface is then things that you have to implement back in your class. Does that follow? So there's two methods that I defined in the interface. Just define the signature. Here is the implementation. And that's why the curly braces over here, the curly braces are not over either side. Does that make sense? Okay. Let's take a break here and come back, maybe 15-minute break here, so call it 2:20.
How did you get those there? Was that implements that put those in there?
You put them automatically.
Okay. Yeah, I just looked away for a second and there they were.
My phone is so old that it just does whatever I want to display.
That's not a good sign. Failed the first time. might try to do a poll on your laptop just to make sure that you yeah, you go back to it and double check if it's not it's back. Go back. I would just do it the other way. Cancel, go back to the previous one. Do you remember actually there's a checkbox you can check the transport type? Oh, yeah, did you use that? I think you can cancel on there. Video file settings. Yeah, okay. We did go visit family, but you know, family comes with drama right now with COVID. So it was good. We were glad to get out because suffice to say, it was the only trip that we made out of town in all of 2020. We were glad to get out of town, but at the same time, like my wife was like, "We're never doing that again. Trying to visit both families for Christmas. This is a bad idea." It was just too much stress. You said what? Sorry. Yeah. Yeah. Yeah, I mean that's usually what I would do is go visit one side with Thanksgiving and another side with Christmas. But we ended up not going anywhere for Thanksgiving because we had our plans to go to see my wife's family. Unfortunately, one of them very likely had COVID, so we're like, we're not going into the house with somebody that has COVID, knowing full well. Like, I guess we're staying home. Yeah. Huh? I just finished. I finally got. Outer Wilds. Outer Wilds. I mean, Outer Wilds. I finally got Outer Wilds. I've been waiting to play that one for basically since it came out, but I finally got it on sale, and so I just finished that. That was great. The other one, the exploration, it's space archaeology basically. Yeah, they do. Well, and as it turns out, I think part of the way I stumbled onto it, somebody had mentioned Outer Worlds, because actually they came out at about the same time. Somebody mentioned to me like, "Oh, did you hear about Outer Worlds?" And I went to go find out about it. And I found Outer Wilds, and I think actual Outer Wilds actually sounded like a more interesting game than Outer Worlds. I mean, I like Bethesda and all, but like, oh, this sounds really unique. Not, not particularly. Huh? No, as I said, we traveled. So Christmas we traveled. Thanksgiving our plans got canceled, but Christmas we went to Springfield, Missouri, and Kansas City, Missouri. Oh, yeah, we got some. We got a few. It wasn't a big. Yeah, it wasn't much. Nothing big there on that front. Just some, yeah, and a few other nerdy things. I don't know. I don't know what's happening here, Mo. I cannot hear you. Because you're not coming through my speakers, and you should be coming through my laptop speakers. Huh? Yeah. Like, I can't, as far as I can tell, I've got all my stuff right. So I should be able to hear you, but I'm not getting any audio through here. Okay. Yeah. Yes.
Sorry about today. I totally forgot about you said you were getting a tablet. I'm like, oh my god, it's Thursday.
Yes.
Now I've got one for TJ when he gets back too.
Is everything installed or are we going to go through the installation?
There's that last page that we need to do. I just asked people to wait until we get done talking about our stuff. Yeah, there's a few settings you need to change. They're not too hard.
Oh my god, it's been so long since I've had something other than the Apple. That's concerning.
Mm-hmm.
You don't have a phone. You have a
Yeah, they call those phablets.
yeah.
Mm-hmm.
I got my book.
Yay!
I'm just waiting on it. Finally came in today, so. It's very small. I wasn't expecting you to be this small.
Yeah, I knew it's in there. I don't actually have a physical copy of it, as it turns out, but I didn't know how big it was.
Oh yeah. I got it in like the box that you get from like the bookstore. And I was like, there's no way there's something in this box.
Well, it's just a quick summary of the syntax. It's not really a textbook per se.
Mm-hmm.
It's just like here's the syntax and
like here's some things you need to know.
yeah. So you can. The point is you can work it out very quickly. Anytime you need to look up something else, this muscle is like that.
I'm doing this in the best way possible. But I don't know why people try to make textbooks about coding. You need to just research what you need to know. Like,
yeah.
I could look through a textbook for 30 minutes to find something. Or I could do a Google search that takes 0.0005 seconds.
I don't. I mean, since I got my degree and graduated, I have felt no need to really go out and get textbooks to learn things. I'm like, I've got all sorts of ways I can learn things. So.
I don't know why, but I probably did just like get a charging cable. Like my brain just like was just like, oh,
If worse comes to
I'm
worse, if you're not getting download this week, we'll do it on Tuesday. Okay, we'll do it on Tuesday because that's when I started doing it. Not Monday. Oh, by the way, Monday is a holiday, so we don't have class on Monday. By the way. Oh no, we just
I hate having like a little bubble that has numbers on them. There's one in the Google Play Store. Just like this, but I don't know the Play Store. Oh my god, looking at people's phones makes me literally just so upset.
Okay. So remember where we left off. So we talked about how to set up inheritance. We talked about how we created an abstract class. We created an interface as well. I think we're still missing Paul, but I'm going to go ahead and go because we're at 2:21. So the next thing to kind of backtrack maybe a little bit is to talk about lists, because I kind of started talking about lists yesterday, but we maybe didn't have all the pieces in play to talk about them. So you'll remember that yesterday I kind of did a diagram with those classes, right? So when we're dealing with collections, right, we've got a few different interfaces and such that we deal with. So array list is the one that you're going to use most commonly. Basically behaves like an array, but it can grow and shrink. You can add and remove things to it. The thing is, the array list implements the list interface, right? So list interface is anything that kind of behaves roughly like an array. That's really not the truth. In reality, it's anything that has an order. Okay, so list says that this is a series of things that has an order. Okay. Now you'll notice in the brackets, you see that there's that E, brackets E. That's because these are generic. Okay, they're generic. You can put whatever type in there that you want. The catch with generics in Java is it can't be a primitive type. The generic system in Java does not support primitives. It has to be a reference type. It has to be an object.
Capital I integer.
Capital I integer, the object, not the primitive. Which that also means you do have some additional weight that comes with. So, for instance, if I'm dealing with the memory, and I've got an array, so here's index 0, 1, 2, 3, 4, 5. If I'm dealing with an array, let's say I'm dealing with an integer array, the data is actually there, right? The data is actually in this cell, which is nice because now all the data is together. Your computer doesn't have to jump around to try and find the particular piece of data. So arrays are very efficient because of that. If I'm dealing with uppercase integer array, the picture is not the same because these are objects. Got it? These are objects. And so remember, with an object, you're never storing the value, you're storing a reference to the value. So that array, the value's not here. A reference to the value's there. So the value actually lives somewhere else. So here's the value over some other place in memory. Right? The value is not in that cell, it's somewhere else. The upside of that is, remember with the uppercase integer, uppercase double, I mentioned that I can put null here now, right? Because I can have there not be a reference.
That's the only advantage of doing it.
Huh?
That's the only advantage you have with an integer array, because you might as well use an array list.
Right. The only thing that it gives me is I can put nulls in this, and I can't put nulls in this. But this is always slower. Always slower. Because this is now random, what we call random access memory, right? Here I can just access all the memory in sequence from left to right, but here I have to go here, and this may be somewhere else in memory. These probably are not, all of these numbers are probably not in the same place in memory, so it has to skip one. So this is something that's not usually desirable. Unfortunately, it's either really or normal option in a lot of cases. Because here's the deal. If I say array list integer, which of those two is that? This is that memory one. It's the bottom memory one. Because I still have uppercase integer, right? So this down here, array of integer, array list of integer, is still a bunch of references, right? So I'm still going to get, this is going to be slower in terms of performance. Does that make sense?
What's the difference between the integer array and this integer array list?
The only difference between these two, the only difference between these two is you can grow and shrink them.
Oh, okay.
So
it's even slower, the array list then.
The array list, yes, potentially. Potentially because you have to go through methods to get everything. These actually usually have, if it stays the same size, these two have about the same performance. You know, there's not really noticeable difference. But there is a noticeable difference between this and that. Got it? Okay, so you do have to be aware of that. And so where you can use actually arrays, it's still desirable to actually use arrays. Does that make sense? So from a performance standpoint. Now, the next question in here. So let's say, you see there's another kind of list. So linked list, and then use integers again here. The actual type doesn't really matter much. Linked list is a different implementation of list. Okay, it still kind of follows the rules and follows the interface in the sense that it is a sequence of things that have an order. Okay, but internally to their memory, they're implemented a different way. So what I start out here first is I have a node. We call that head. And then I have other nodes. So this is the one that contains that first element. I have another element, another one that contains the 1, another one that contains the 2, and then this just doesn't point anywhere, basically. Right? This points to null.
That's the end of the chain.
That's the end of the chain. That's how a linked list is stored. So you have object, 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 object. It's a sequence of objects. As it turns out, because of this being random access, these are kind of similar in Java. This is still in general, I would say this is usually slower. Usually slower because, again, you kind of have to jump around in memory. The biggest problem with this, and where this becomes different, how do I get to index 2?
You have to go through.
I have to start at the head, and go through there. I can't just jump to head 2. If I want to go to index 2 here, I just go there, right? I just go there. I don't have to do any fancy footwork to get there. But if I want to go to a particular index, so the interface on there, you say dot get to, right? That has to start at the head and work its way all the way down to the one you ask for, right? So if I say I want to get the 100th element, that's very slow because it has to go through 101 elements to get there.
What is it good at doing?
What is it good at doing? In theory, what it's good at is adding and removing elements. In theory, it's easier to knock that element out because I can knock that out and then point the pointers like that, and the element's gone. In theory, that's faster. The problem that always occurs is that people say, I'm going to remove that. And how do they remove it? They say remove element 100. And they give it the index. And now it has to go through all that chain to go find it and remove it. So if you remove it this way, you lose all of the benefits of an array list. Of the linked list. What you have to do is somehow give it a cursor, basically to say, hey, you're already here. I already went and found you. Because inevitably what you do is your first loop is to kind of loop through here and find the thing you need to delete, and then tell it to delete. So you need to somehow tell it to delete what's there. So what that means is, what you actually use is what we call an iterator. And you can kind of think of the iterator as, if you do a regular for loop, you have that counter variable I or J or K. That's kind of your iterator. You can kind of think of it that way. But internally, the iterator is not a number. It's a pointer to the node that you're on, right? So the iterator has a few methods. It's got hasNext, which says, is there a next method? It's got another method called next, which takes the iterator to the next method, next object, next node. So you can think of this as kind of the I++, right? So this is what you would put in the middle of the for. This is what you put in the third piece of the for. And then it also has a method which some iterators implement, it's not required, called remove. So you can iterate there and then call remove on the iterator. And that's how you get the performance out of a linked list. Nobody does that. That's how you get out of there, is if you're going to get the performance of linked list, which is add and remove, you have to use the iterator directly.
We're almost never going to use a linked list.
Don't use a linked list.
Never. Okay.
Yeah. Doubly linked list still has the same problem. So doubly linked list just means there's another link going backwards. You can still do that. The doubly linked list doesn't help me with that because I can go back and forth here, right? If I'm currently at song 2, song 3, song 1. The only place where it's helpful is because the adding and removing is a little bit is faster. As long as you're already there. As long as you've already iterated there.
Linked list is like Windows ending. Don't worry about it.
Yeah.
Disregard it.
The reason that it exists is because there's kind of a perceived performance problem here. If I remove index 2, I can't just leave it like that. Now I have an empty slot, right? So in the world of here, I could put a null there, I could put a 0 here, but it's still there, right? So I need to fill that hole. So what we do with array list is what array list does is it transfers all those over. So when you remove something, this index gets pushed here, here, here. So removing something from there is kind of expensive because of all those copies. As it turns out, those copies are pretty cheap. So it's not usually something that's worth optimizing out. Because as it turns out, it usually comes out in the wash.
If you would hard code an index in that system there, that would be problematic. Because you get a different result.
Right. Yes, that is a problematic thing because if you assume that this is at index 3, now it's at index 2. Right? This object has just moved. Does that make sense? So the indexes are not stable. If you remove something, then everything after it slides back. But that's true with both of these, right? If I remove this object, this is now index 0, and that's index 1, right? So that's what you need to understand, is that there's two completely different versions of list, right? And they behave entirely different in terms of performance, right? On the outside, the interface, the methods that you have are the exact same. On both of these sides, it's add, remove, get, and set, because those are defined by this list interface, right? So they have the same methods, but they perform differently in terms of performance. Does that make sense? So now, typically when we're working with lists, if you're, say, accepting it as a parameter to a function or something, I'm typically going to accept it as one of three things. I'm typically going to accept it as list, collection, or iterable, depending on what makes sense. Okay? So as we're kind of talked with hierarchies, we talk about inheritance, right? A collection is an iterable, a list is a collection, an array list is a list, right? So I can safely upcast all the way up to 0. Okay, so an iterable is anything that gives given an iterator. And specifically anything that can give an iterator, well, that can work with the enhanced for. Because the enhanced for, that's all it needs, is an iterator. So that's, if you're using a linked list or you're using an array list internally in there, then we use the iterator. Okay? So iterable, I just need to be able to iterate over it. Collection, when it adds to that, collection allows you to add and remove things from the right? So if I need to be able to modify it, not just iterate over it, then it needs to be collection. Does that make sense? And then list is if it needs to have order. Okay? So if we think about some common operations in here, and let me pull this back up. So if I want to have, and go to another slide. So let's say I want to do some common things. So first of all, I want to say where would you guess in that hierarchy that method's defined? I think it may actually be, let me just clarify, Java doc. Actually, Android. Let's just go to Android. Android make sure I have this. So if I go to the iterable, you can see it's an interface, right? So iterable is an interface, and it has a method called iterator. That's the one we're interested in. Back to here. So the method is iterator. So if I'm thinking about, I want to do an enhanced for, so like for item in
Enhanced for, does that just mean for each?
yeah. Oftentimes because the word each actually isn't in the syntax. We a lot of times the textbooks and people that talk about it, they'll call that as they'll call that the enhanced for. So you'll hear it by both names. So that's implemented using iterator, right? So iterator exists on the iterable class, right? So if you want to do that, then this needs to be what? What class does this thing need to be? List here. What interface does it have to implement? Well, it has to implement iterable, right? So if that's all you need to do, then it just needs to be iterable. If I want to do list.add, so add something to it, where do you expect that method to be declared? Collection, right? So remember, collection allows me to add things. So that would be, those are in collection E. Okay. So if I want to add things, if I want to remove things, same thing, right? But if I want to do things like, if I want to do like get index or set,
I'm not understanding what iterable brings that collection doesn't.
Well, every collection is an iterable. Every collection is an iterable. So these are kind of the methods that are available. So you got list, set, and this would be the index and the item. And if I want to dot remove index, these things are defined on the list.
So an iterable could be a parameter.
Yes.
But why would you use just that? Why not just a collection to add a it? It just seems easier like just to skip that.
Yeah. So I'm getting there. So those are some of the methods you need to know about. Got it? Okay. So let's say now I want to do, let's say I want to do a, oh, that made the font bigger. I just wanted to make my text box wider. Let's say I want to sort, if I want to sort it, okay, what type does that need to be for me to be able to sort it? If I was going to write a method to sort a list of things, or a group of things. Can it be just iterable? Is it iterable enough to be able to sort it?
No.
No, because it doesn't have an order. What about collection? Huh?
Collection, yeah.
No, because again, collection doesn't have an order. What gives me an order? Huh? List. So in order for it to be sensical to order it, it needs to be a list or an array. List or an array have an order. So I could say, let's sort a list that makes sense if I want to write a sort method, because this is kind of going back to your labs, right? So I could sort a list. What if I want to say find max? What's the minimum that this needs to be? Collection?
But the only thing you can do with the iterable is just go over it and like print it.
So let's think about this. Do I need to be able to find the maximum of something? Do I need to be able to add and remove? Do I need to be able to modify that list? No. I only need to be able to iterate over it. The only thing I need is to be able to iterate over it. So I can find the max of anything that's iterable. Does that make sense? I can find the max of anything that's iterable. Because all I need to be able to do is go through them one by one and say, is this one bigger than all the ones I've seen before, right? So the order of them doesn't really matter, right? I'm just returning the biggest one. And if I were to call max a second time and it went through the objects in a different order, would it matter? Probably not, right? I could go through it backwards and I'd probably still get the max, the same max.
Is the point of this to
Mhm.
upcast something into an iterable for performance? That's the only reason.
For generality, because if I say it can take iterable, then it can take any of the things in the vast world of collections. Remember I said that there's other things that are outside this chart. You got it? There are other things, there are other collections that exist. So if we're thinking about that, min is the same thing. It only needs to be iterable to find the minimum. Okay. If I want to maybe make a copy of it and turn it into an array, what's the minimum that it needs to implement to make a copy of it? What's the minimum requirement? Just iterate over it. So I can make it a copy of it. What if I want to? What am I thinking? And so maybe I say find person, and I have something as some sort of list or something of people. What should be the data type here? I'm going to say find a person and return that person. Huh? Okay. So I can implement that with iterable. What, on the other hand, if I want to say, which specifically here I mean, given a name. What if I want to say find index? So instead, I want it to find where it is in the list. Not return it, but tell me where it is in the list. What's the minimum that it can be?
List.
Why list?
Because that's the only thing that's going to be ordered. Yeah.
It's the only thing that has an order, so I need a thing here. So really, this needs to be at minimum list. Would this work if I said array list, people? Would it still work?
Yes.
So I hear a yes, and I hear a hmm. Who's hmm? So it will work as long as the people is an array list. What if the people is in a linked list? Right? So this, if I define my signature this way, I can take a linked list or an array list. Take any kind of thing, either of those. But if I say this, it has to be an array list. Does that make sense? I'm making it more strict. So generally, we only make it as strict as it needs to be. And that enables us to use other data structures where it's appropriate. Okay? Because there's a lot of times where you may want to use something else. Got it? So as you're defining those methods, like find the biggest thing, find the smallest thing, you know, find somebody with this name. You know, think about what those input parameters should be. Okay?
Well, when we're doing, say, like these problems for homework, creating something first, but we're going to say, like, identify what the maximum largest element is, saying, okay. And you would just, I don't get why you just wouldn't use list every single time, because you can iterate over a list, but you can't iterate over
So I have something, for instance, like a set. A set is something that is a collection, but it is not a list. Yes, most of the times you can get away with just saying listing. Most of the times you can get away with just saying listing. But what I would try to recommend you avoid is saying array list most of the time. I would say only use array list if you know it has to, for some reason, be an array list. Because most of the time, linked lists and array lists are so similar that it doesn't matter. There's also, given that, there's also a list called a read-only list. I didn't put that on the chart, but that does exist, where you can create it, but then once it's created, you can't change it again. That exists, and sometimes you'll get those as well.
So list over array list.
List over array list generally.
Yeah. What's the difference again?
So one is implemented with array, list is implemented with you don't know what. Right? You're saying what is the implementation detail behind it, right? So is it implemented this way or is it implemented this way? Most of the time it doesn't matter. Most of the time you should write your code assuming that it's either one. Does that make sense?
Okay. So there's a list you can't call max iterable. You can't take that as your parameter, right?
No, you can.
You can't.
Because remember, a list is an interval.
Okay.
A list is a collection, is an interval. Correct. Yeah. Iterable is not necessarily a list, but all lists are iterable, right? So they define some methods. Anyway, I think we've already spent more time on that than I meant to, but I wanted to give you some introduction to where that is. So we kind of talked about the generic side of it. You'll again remember you see what's in the brackets. That's the generic argument. Okay, so what I probably want to do is do a quick code example. So with this, Remember, we've created employees, we've created customers. So public, let me create a method here. Public static, this is back in main. And so what I want to do is I want to find the customer. I'm going to find a customer, and let's say find youngest customer. So given some customers, I want to find the youngest one. Okay, that's my goal. So I'm going to find the youngest customer and return it. What do I need to pass this function? Should it be array list? Should it be list? Should it be collection? Should it be iterable? What are my requirements in order to be able to find the youngest? Iterable. Right? I just need to be able to iterate it through. So I'm going to say anything that's iterable, I can find it. Now, I'm going to say iterable customers. So I have to be able to iterate through it and get customers. Because if you give me employees, well, I'm not going to be able to find their age, right? Okay, so let's start with that. Okay, what I need to do first. Somebody give me a hint. What should I do first with this here? What's my step one?
Find the youngest.
Find the youngest.
Int youngest equals integer dot min value or max value.
But is that the youngest? That's just their age, right? Mm-hmm. So if I was going to call this variable, that would be the youngest age.
Yeah.
Okay. So remember that iterable means that you can get an iterator. And what I want to get into is the actual iterator object here. So the general algorithm, right? I think you're starting to recognize this is a case of find minimum, right? Because I'm trying to find the minimum age, okay? So if I want to find the youngest customer, then I need to, there's two ways to implement that. You can either start with the variable that is the lowest value, tracking the lowest value, or I can start with, and I can initialize that like you've done to max value. The other way I can do this is I can start by assuming the first one is the youngest, right? If I assume the first one is the youngest, then I can go from there. So what I'm actually going to do, the first thing I will ask for, and I'm going to get into the iterator here, is I'm going to actually say, give me the iterator. So the iterator of customers, so this is kind of my pointer, and usually I call that ITR. So I'm going to say customers dot get dot iterator. Yeah, dot iterator. So now I've got an iterator. Remember what I said, the methods are the variable. So iterator has the methods hasNext, has the method next, has the method remove, right? And in this case, all I need is hasNext and next, right? So in here, I'm going to say first thing I want to do is let me say customer youngest. So the current youngest just becomes iterator dot next, right? So that gives me the first thing in the list. You with me so far? So just say
line 43 customers dot iterator. I don't understand what's going on.
This is gives returns an iterator.
Returns an iterator.
Yep. So
what
lists
does that mean? Like
lists have this. think about it as your I, right? So think about this in here is I. That's the index of where you're at in your loop,
That
right?
starts the process.
So it's going to start the process, and right now it contains the number 0, right? Because we're the first index. So if I say iter.next, that's going to give me the first one, or it might give me null. It might give me null if we're already at the end of the list. So what I'm going to then say, let's loop through all the items, and this is where, while loop is helpful, because I can say iter.has next. Okay. So if it has a next, then let's ask for it. So the current customer would be iter.next. So each time through this we say, is there a next one? Ask for it. Is there a next one? Ask for it. Does that make sense? So every time we ask next, it moves the counter onto the next one. So first it's at 0, then it's at 1, then it's etc.
That's like,
right?
that's
So
sort of like,
what do I need to do here?
Something like
Yeah, yeah. It's basically, you can think of iter as that index sub I. Okay. So what do I want to do? I've got the current customer. How do I know if that one's younger than my youngest? How do I know if that one's younger than my youngest? Zach.
I'm blanking.
Okay. Vincent? Okay. That's right. Yep. How? Okay. So if I say current.getAge, and what comparison operator should I use between the two? Okay. So if the current one is less than the youngest, right? Youngest.getAge, right? So if that's true, if this one is younger than the youngest, then replace the youngest with the current, right? So then when I get to the end of this, I just say return youngest. Does that make sense? And that's actually kind of breaking out what's happening inside of that enhanced for, because it automatically runs next and has next for you.
Let's say that again. Why is that better than the next for?
So the reason I needed to do this is because I needed to break off the first and do something special with the first. If I just jump into the enhanced for, how do I get the first, right? That's a problem. But if I use the iterator directly, then I can just ask for the first and go from there.
But the way with the max value, setting,
so does that make sense in terms of like generic purposes? So the other thing I would point out, I'm doing things in here, for instance, that are there's a lot of redundancy in here, for instance. So like I have customer appears in a lot of places, even though maybe it doesn't necessarily, because if I wanted to use this with something else, it's in a lot of places, customer. I'm going to say that a lot, so I might want to make a more generic version of that doesn't rely on that order there. Other things I might want to do, I might want to say that this doesn't necessarily mean, let's say I had subclasses of customer. Here I'm assuming that I will never have I guess actually it doesn't matter too much, but I'm kind of assuming that I don't have a subclass of customer. But if I did, I would need to change this a little bit to say that it's an interval of something that is either customer or subclass of customer. So you can typically say, like E extends customer. I can declare a generic type argument there. In reality, I don't care what that type is. So I could do, there's something called erasure in generics in Java.
I'm not understanding what we're doing there.
So I can say it's something that is either customer or a subclass of customer. E extends customer. That's just if I can forget what the type is. Unfortunately, I can't forget what the type is, as you've maybe already seen. It says, oh, you can't do that because this returns something else. So maybe I'll go back here. Let's define E, and we'll say E extends. Go back to what we had here. E extends customer. So E is either some class, either customer or some subclass of customer. That's what that says. So what that means is then I can go put E in all of these places.
So E is generic. You can do this every single time, and we're using
Pretty much,
something that's
most of the
a
time.
class. E extends.
Yeah. So I'm saying, E doesn't really have to be, the type of element doesn't really matter, as long as it's a customer or some subclass. I could do a similar thing if I wanted to say work with people, right? Person, we've gotten a subclass there. So if I wanted to say, give me, the sort the people by name, right? Then I could do, say, E extends person.
I'm not understanding the second E in line 42.
So that's the return type. It's going to return one of those. So I've got a basically, I've got some sort of collection of E. So I'm going to return one of those things. Whatever the type you pass in is the type that comes back out.
Right. I'm just like trying to figure out, like, let's just say it returned nothing, and then the word public static void. What takes the place of the word void in its entirety?
E. E is the return type. That's the whole return type.
Okay.
It's another variable. It's a generic type variable. But instead of being like a value like 3, 4, 5 or a specific instance of an object, it's a type. Right? So your parameters here, like customers, you're passing in a value or a reference. You're passing in a list. But your type parameters, you're basically another kind of parameter. You're passing in types instead of passing in values.
Okay, if you're returning E, which is a generic type, that could be anything.
Yeah.
An integer with a big I.
It can't be because I've defined E as only subclasses of customer. Integer is not a subclass of customer. So this doesn't work with an iterable word integers.
Okay. So that's normally not something you would see that what's after static in between the brackets there.
You'll see that a lot. You'll see that if you're working with generics, you're going to see those kind of things.
All right, I'm trying to translate this into like what I'm going to do when I'm working with classes and I'm returning an object. Generally, I just want to do that.
The big place that you're going to see this is when you're working with lists, right? This is basically where you're going to see that. If you're working with lists and trying to implement algorithms, especially like you're doing labs for Code Wars or the lab for console, I've asked you to do a lot of things that are sort of generic-ish. Okay. So that's to give you just an intro to some of that. Obviously we've got a whole semester to dive a little bit deeper, but I want to at least give you a little bit of intro to what that looks like.
So there's not a lot of these on the lab, correct? It's just more single list or
Let me pull up the labs. So you're asking about where is their generics? Okay, so you see the second section that says lists or strings. Okay, write a function that returns the largest item in a list. I said largest element. Did I say what type the list is? Did I say what type the list is?
No.
So is it a list of strings or is it a list of integers? Is it a list of longs? So that one inherently is kind of has some, generics built into it.
So you can type in, say, like, I'm just working
Did I say the type of this? So 12. Did I tell you what type of list it is? Okay. Generic. Write a function that checks whether an element occurs in a list. Is the type defined?
So if we're creating a list, it would just be lists and then less than equals greater than. Those brackets. I don't know how to define them. How do you refer to those?
Yeah, the type arguments.
Type arguments.
The type arguments.
So it would be list type argument.
Yeah.
E.
So it needs to at least, it doesn't necessarily need to take iterable, but at least it needs to take a list of some type, right? So that list may be a list of integers, it may be a list of something else. So write a function that returns a list of elements that are in odd positions in the list. Did I specify the type? So a lot of these, if you pay close attention, I did kind of, I was kind of hoping for something generic. I'll still give you credit if it's just list of integers.
When we create it, it's not generic then, it's just when you iterate over it, right?
No, it's generic when you've defined it. You define that as part of your signature. So where am I here? So because I have this type argument here, I've defined a type E. That's what makes it generic. So like if I was going to find, what was the first one on here that, okay, so find the largest, right? So if I was going to say that, I would say public static, and it needs to be some sort of E here, and it would find right. Now, what was the type here? Should it be array list? Should it be something else? Huh? So just list would be fine. But it'd be a list of E. I need to import java.util.list. Right, so that might be my signature. And so you'll notice that there's a type argument here. Right?
So the type is generic and the name of it is generic. The E that's after that. I'm still not getting that.
Yeah. So this declares that later, right? This declares in this function, this is a generic function, and we're going to use E later on, right? This just says from here on out, I've defined E as a type argument. And then I'm going to use it as my return type, but I'm also going to use it as the type of my parameter. Does that make sense? That E can then occur anywhere else from there on out. It's like you're declaring a variable. Okay, now you're going to run into a little bit of problem here, because if I want to find the largest, what do I need to be able to do in order to be able to find which one's bigger? Because I can't actually do that with anything. There are some things that this won't work with. So for instance, if I wanted to give you a list of colors, can I find the largest color?
No, I sorted by alphabetical order. So violet would be ahead of blue. You know, greater. Doesn't work like that, doesn't it?
Well, now you're assuming that they're strings, right? Now you're assuming that you're passing me a list of strings. That's a different question than a list of colors, right? If you give me a list of strings, yeah, I can sort those.
Would you extend it to integer? Or...
So what should I say? Well, if I say this extends integer, right, then it actually only works with integers. If I say, if you do some Googling, you can find out, oh, well, an integer is a number, and a long is a number, and a double is a number, etc. So that would work with numbers. But what's not a number? A string, right? So if I say that, it'll work with numbers, but it won't work with strings. It's comparable, because what I need to be able to do is compare them, right? So I need something that's comparable, and as it turns out, it needs to be comparable with itself. So that would be the proper way to define that interface, that signature. Does that make sense in terms of generics? Okay. So as you're reading up on generics, and I would recommend, what was it, chapter 22. Generic, we'll kind of go over generic classes, and I believe generic methods is in here too. It'll give you a quick kind of summary of how to work with some of the generics.
What we just defined there. Okay. Yeah, I meant that. It says you have to return something, right?
Right.
A comparable would be just any number, right? So if I type return 0, why do I still get an error?
Well, because 0 is not E. 0 is not E.
Okay. What would be something real quick to type in there?
Well,
return E.
You've got a list of elements, right?
Yeah.
What is that list? A list of elements is of what type? List E, right? Yeah. So what's inside of that list? A bunch of E's, right? A bunch of elements. So if I said return, as it turns out, return null is acceptable, because your generic types have to be reference types, so null is always okay, because it can't actually list int, lowercase int, it can be list uppercase integer, but you can't do that. So null is okay, or I could say items.get 0. That works, because all the items in the list are E.
Return item get 0. Because at index 0, that is...
At every index, it's an E. Because I've defined it's a list of E.
And E in this case is it's extended to be comparable, so it couldn't be a string.
Right. Well, no, strings are comparable.
Oh, they are.
Strings are comparable, numbers are comparable, integers are comparable.
What would not be comparable?
Colors.
But a color would be a string.
No, a color is not.
Hexadecimal?
Color is not necessarily a string.
Color is not a data type, or is it?
You could define a color data type.
Okay. All right. So
and there are actually several color data types in Java. So there's a color data type from AWD. There's a color data type in Android. They're different. So you could define a color as a few different things. You could define a color as a number. You could define it as a string. You could define it as a numeration value. But realistically, what if you define a number as an object that has both a name and a hexadecimal value. What if you define an object that has both of those? Is that then comparable? Maybe. But realistically, we typically don't sort colors, right? We don't usually assign those a sequence. Does that make sense? Typically, those don't have an assigned number, and that's why I picked color out, right? You can use any letter you want there. We usually use E shorthand for element. And you'll also see, if you work with maps, you'll see K and V, which is short for key and value. So, but technically you can use any letter you want. So we talked about a few of these things. Did we talk about static variables? We briefly kind of mentioned them. Remember, static is the idea that it doesn't need an instance, and it doesn't need, that you can use it without an instance. And remember that main, we're kind of putting those static because we're running without instances. Does everybody remember what overriding is? Any questions on overriding? Remember, overriding is just declaring several methods with the same name but different signatures. I won't really talk about, well, I guess the annotation. Typically, when we mark a method as override, I'm thinking override. Override is when you're declaring how it's different in a subclass. I'm thinking overloading. So overriding, and you'll have like that. Trying to remember if there's, access levels. We didn't talk about access levels, so I needed to talk about that. So can you see the chart up at the top? So you got public. Public means it can be used completely unrestricted from everywhere. Protected means it can be used by any subclass. Protected has a very weird oddity in Java that's been there since basically the beginning of time. I don't really think it ever should have been there, but it's a relic of times gone by. Protected has another exception. Protected not only can be used in subclasses, you can actually use it by any class that is in the same package. By any class that's in the same package. So one of the things that I did here might potentially be a problem. Remember how I made these protected? Do you see that? Name, ID, I made those fields protected. Well, what package is main in? AWD, Ranken, Paul Smith. It's the same package as person, right? So actually, in the world of Java, I'm going to write this, which normally you would say is a bad thing. That's valid. Because protected gives it access not just to everything that's a subclass, also gives it access to, then you can access it with anything that's in the same package. Does that make sense? Any class that's in the same package can also access it. And then you saw the third one on there. So if you leave something out, that's package access. So if you leave that off, any class in the same package can access that member. Does that make sense? Does that follow? It's weird. And honestly, it's very seldom that you should use that. Because if you're,
Use protected.
We'll use package level access, or take advantage of the package level access that protected gives you. Because package, well, that means you have this class over here seeing basically the private variables of another class over here, right? And what happens, if you do take advantage of that, one of the things it locks you out of is moving the classes around, right? Because now these two classes are tightly intertwined and they have to be in the same folder. Does that make sense? So that exists there, but typically, and you can see that that's not the same as private, because private is nothing can get to it, but package is anything can get to it that's in the same package, right? So if all of your classes, which are there right now, right, we just put all our classes in the same package, not a great thing. Usually you create a bunch more packages to relegate, the limit what can get access to those numbers. But cool. So put private, don't leave an access modifier off because that's package level access. That's basically what it is. Anything in the same package can get to it. That's the default. Which is a weird default, I will say. Vincent, did you have a question?
No.
Okay. No, I'm just checking. So that's what that is. Sometimes that's called package private. I don't want to talk about too much there. It is technically possible to have more than one class in a file. So for instance, I could put the employee, the customer, and the person class all in one file. The catch is that only one of those classes can be marked public. The other two have to have package access. I would say usually the industry recommendation is only ever put one class in a file. That's typically the industry recommendation. So you've got person, you've got name, you've got employee, put those in separate files. That's typically what people want you to do, even though you can put multiple classes in one file. Okay. Are there any, so I think I'm going to kind of call it here, or, one I should jump down to. Exception handling. Exception handling, you're basically familiar with it, so try and catch. We did a little bit of that already. There is also the finally block. So remember with, can I make this font bigger? Because it is really small. There. So remember, finally comes at the end. It is optional. You can have try and finally and skip the catch. It's either try finally or try and catch. Those two options are okay. Does anybody remember what finally does? When does finally execute? Okay. You said runs whether there's an exception or not. So in this case, let's say we try to open a file and the file is, in this case, it's not there, right? So the file's not there. So it's going to throw an exception. You say file not found exception, it goes in here, right? So it runs the try, runs the catch, and it runs the finally after all that stuff. Okay. Now what happens if that missing.txt is actually there? Does it run the catch if there's no exception? Huh? No. Okay. Does it run the final? Yes. Okay. One of the key things to remember is finally runs always. Regardless of what happens, finally always is guaranteed to run. Okay. Whether there's an exception here or not.
I see it's closing.
The other thing, let's say, so here file reader, file not found exception. That's one possible exception. What if we get another kind of exception? Does this catch other kinds of exceptions? No. So they will continue, they will be thrown, right? They'll go out of here. We may not catch that exception, right? Because we may not have registered a catch for that particular type of exception. So like if there was a no reference exception here, right? Then we would get a no reference exception. The finally still runs. Okay? The finally still runs. If I were, a lot of people say, well, okay, it kind of sounds, the catch where most people get confused and think, well, why do I need this finally? Is what happens if I knock off this? What if I just say, let's put it after the try and catch? Well, that always runs, right? If I remove this from the finally, does it always run? Remember, the finally guarantees that it'll always run. So there's a reason that the finally is there. Strip off the finally here, strip off the closing bracket here, just put it at the end. If there's a no reference exception, this code never runs. Does that make sense? The code afterward.
Really, I know what finally is,
Okay.
and I can't remember using it.
So the recommendation and the place you want to use finally is anytime you need to close a resource that you've opened. So specifically, that's usually files. So if I open a file, which is what I'm doing here, I'm opening a file, I need to make sure I close it because otherwise it will stay open. Is that wrong? If I don't close it, it will stay open. If I do a database query, let's say I go select star from employees, right? That's going to open a database query. You get back to what we call a cursor. That cursor stays open until you close it. So if I go ask for all the employees, maybe I go read just the first 3, and then I just run off on my merry way because maybe something went wrong and I failed to read the 4th one, that connection to the database is effectively still open. Right? So I need to close database connections here. I need to close files. I need to close any sort of other network connection that I have.
I got a general question about the catch statement there, the one that's in the final.
Yeah.
Is I've seen, at least in the same, because we've had exception EX. Exception is just, as opposed to IO exception.
Yeah.
Exception is just a general garden variety exception, right? It could be an IO exception or something else, right?
Exception covers, is the base class for exception.
So it's like any exception. That's all. I mean, it's generally what we want.
Exception is basically, well, is sometimes what you want. That's the kind of the easy. I was being lazy when I wrote exception, right? I was trying to not catch all the different things. In general, you do want to call out the specific exceptions that you're catching and not use exception. In most cases.
But that's kind of like a catch-all, right? If you have an IO
It is a catch-all, but
EX,
you want to use that. You want to use that sparingly. You don't want to use it all the time, right? So there are cases where you want to say, I'm okay with catching every exception, but most of the time you don't want to catch it.
Why would you want an exception to crash your program?
So
Why would you ever want that? I mean, it's you always want to be able to have a.
Sometimes you do want your exception to crash the program.
You do?
Yeah.
Like, what would you want that?
So sometimes things get so bad they're not recoverable. That is the truth. And so sometimes the best thing to do is let the program crash. Sometimes you get into a boat where it's not possible to solve the problem, and so you have to say, well, this program needs to restart. So we're going to go ahead and let it crash. So you're saying if there's something unanticipated that happens, we'll just let it crash, and then we'll deal with it, and then at least I'll have a log that it crashed, right? The problem with catching the exception and dealing with it, oftentimes from a user's perspective, it can look like nothing went wrong. If you catch the exception, program keeps running, user's like none the wiser, especially if you don't show them an error message. You don't show them error message, they're like, I clicked the save button and nothing happened. Right? It's just actually the most common place for that to occur. They hit save.
Okay.
They don't see a progress bar coming up or anything. They're just like, just nothing's happening. But it's not saving. So in that case, it may have been better to have the program crash, because then at least the user would know something's wrong. Right? So sometimes that's the trade-off that you have anytime you put try catch in, is because you're trying to deal with the exception and make it look like to the rest of the world that nothing happened, that nothing went wrong. Right? So sometimes it's better to effectively let the program crash so that you know that something went wrong. Does that make sense? There is a weird thing in here, and this is a Javaism which irks me to no end. You'll notice in the finally, we've got another try catch.
The whole point of a finally is to avoid the.
Well, the whole point of a finally is to make sure something always happens. The whole point of finally is to make sure you clean up after yourself. One of the things that I had to do here, you notice I had to move my file variable up and out of the try, because I need to be able to access it down in the finally. Because if I had just declared file reader file up here, then I wouldn't be able to access it in finally. That's one thing. You see that, right? The other thing that means oftentimes is and it does happen in this case, if file reader throws an exception, then file never gets assigned a value. If this constructor throws an exception, what is file? Well, file is still null. Everybody with me on that? If the constructor throws an exception, this variable is still null. So if that constructor throws, you'll get that. Sometimes that's where the exception will be. Sometimes it'll be later down. Here, there's only one line. So then later down there, you would actually have a bar. So anytime you get into finally, you have to check if the thing is null or not, because it may have never been created in the first place. You see that? That's the reason that they do that, is because it may have never been created. File.close, that's how you tell something to close. If you're doing cursors, it's like cursor.close. Problem is, remember we talked about interfaces, right? So close is part of the, it's anything that implements file reader, any of the readers, any of the IO streams, anything that implements the closable interface has to implement this close method. Unfortunately, the way that interface is defined, just like every other method in the IO streams interfaces, that method can throw an exception. It declares the close can throw an exception. What do you do if you try to close a file and it throws an exception? What if you do? I'm saying to try to clean up after myself. I want to close this file, and it tells you you can't close it. What do? Yeah, you give up. You say, there's nothing I can do with this. So as it turns out, you'll see this a lot of times in the finally, this quirky pattern. Check if it's not null. Try to close it. If it fails to close, then just ignore the exception.
We're not going to need this in these assignments we have now.
Not right now. Not right now.
Okay.
Not right now. Yeah. So those are kind of, you're going to see that weird syntax. That has been with us for a very long time in Java. And if you do Java Professional, I guarantee you'll see that littered around the program. There's a new syntax in Java. We call it try with resources. What you do is you declare the thing that you need to close, the resource up here. You see how you're declaring it try in parentheses. It's actually not in the try block. You say open the file, and what this actually does is it automatically does the whole filing thing for you. Automatically closes it for you. So if you do have resources you need to open, then that's worth knowing about.
We're using Java 7. I thought we were using, I want to say 15.
We're using 15.
Okay.
What it's saying is this was added in Java 7.
Oh, okay. Okay.
So as it turns out, remember what I said we're using 5.0 and greater in Android? Before 5.0, this is not supported in Android.
Okay.
Because, yeah, it's somewhere around it. Because Java 7, this support didn't get into Android until later. Anyway. Yes. Yep. Yeah. It runs all the time. So if I say inside of my try or inside of my catch, I say return, it's still going to get to run before the function returns, which actually means you can do a quirky thing where you can actually return twice using finally. You should really not do this, but you can. So you can say, like at the end of your try, you say return. In your finally, you could also potentially say return.
Return what?
It would return the thing in the finally.
Return what?
It would ignore the other one. But that definitely trips people up sometimes. It also means that you can say return and be all good, and then an exception is thrown in the finally clause, which means the function throws an exception instead of giving you your result.
Return what?
So usually you anticipate return is the end of the program. Yeah, finally gets to run after that.
Return what? What are you talking about?
So, where's my editor? That function will always return 1. Not 0.
It's only return one thing.
Or this function will always throw an exception. That happens. I've done that accidentally a lot of times. That's surprisingly it's surprisingly easy to create that situation where you throw an exception. Huh? Yeah. The one thing that's weird about Java, and I must have skipped it over in the documentation. Java does something different than most other languages. Typically, you have to declare what kind of exceptions your function can throw. So you may see something like this, throws IO exception. So what this says is that your exception can potentially, it might throw IO exception. It doesn't guarantee, it doesn't tell you what the conditions are for it throwing IO exception. It says that it might.
What value is that? Is it just a note?
Well, what that means is the function that then calls this has to try and catch the IO exception because it might occur. So this function has to be wrapped in a try and catch. Or it has to declare that it also throws exception. The IO exception.
Oh boy.
right?
It's just the, when you're supposed to go there,
So you'll notice with the null pointer exception, I didn't have to do that. So let me pull this off. Throw new file found exception.
Where's your catch block?
I don't have one. So here I'm saying throw this exception. I haven't declared that this function can throw those kind of exceptions. So it's not happening.
there's some stuff.
Yes. So there are some exceptions that you don't have to declare that you might throw. So some exceptions you have to, what we call check. Some of them are checked exceptions where you have to, you're forced to. So like if I try to call this method, I have to check for file not found exception or some parent class of that. But as you saw with if I throw null pointer exception, I don't have to catch it. I don't have to catch it. Okay. The way that you find out which it is, look at the null pointer exception. You see what it extends. You see it extends runtime exception. Anything that's a subclass of runtime exception is not checked. You don't have to put a try catch on it. So runtime exception, null pointer exception, illegal argument illegal exception. There's a lot of those under the runtime exception banner. You don't have to put a try catch on it. You probably still should, but well, sometimes you still should. The catch is basically the things that they're putting into runtime exception. The expectation is that rather than catching with the try catch, you prevent them from happening in the first place. So usually, like null pointer exceptions, usually you can prevent those from happening just by writing the code correctly. Does that make sense?
No, but
So
I won't use this anytime soon, and I feel like I'm
you'll
skipping
run
to
in,
the last chapter of the book. On,
you'll run into it
second
sooner
class.
than you think.
Yeah.
Yeah. You'll run into it sooner than you think. So if you see something that says like, hey, you know, you may see something that requires you to then add throws to your method or things like that.
How did you create that whole file?
I just went to it. So you can right click any of these classes and say go to
Okay, it's like built in.
implementation.
This is like part of Java.
Yep, part of Java.
Okay.
It's part of Java.
Okay. And in plain English, what's a null pointer exception? You're just pointing to no references.
Yep. So if I have a null here, I try to dereference it, whether I access a field or a method of it.
Okay, so there's no reference exception. This is Java's way of calling it.
Yeah, null pointer exception.
In JavaScript, it's no reference.
Yeah.
Here, it's null pointer. Okay.
Yep, same thing. Same thing.
I don't understand why Android 5 is such a big deal.
Android 5 is a big deal. That's why we're starting at that, because there's a lot of things in KitKat that are a huge pain in the ass to deal with.
I remember tons of apps that were like, you have to have this version of Android to run it. It's like, wow.
Yeah.
You should do that.
Yeah. Anyway, let's go. You get back to labs. So I'm gonna call that here. I don't think we've touched on everything in the quick reference guide, but I think that we have enough to kind of move forward. Things that we should talk about in the future. I would strongly recommend you read chapter 21. Read chapter 21 and spend some good time digesting it, because 21 is really, really important. Um, things that will be helpful later in the world of Android. Generics, and we kind of touched on generics, and we touched about lambda expressions. So if you're looking at stuff new, definitely reach out to this point. Yes.
So are everything due before class tomorrow? Or
End of day on Friday. I think I put all the due dates at like midnight on Friday.
Yeah, that's just
But we should have, I think we covered everything on the, homework quiz. So you should have all the information to do this, I believe. If not, let me know and we can discuss. But
that's pretty easy stuff. Right?
It should be, I think all of this is either in your textbook or online. I think there's a thing or two that's not in the textbook.
Mm-hmm.
But we did just talk about, like the last one, I just said something about runtime exceptions, right?